Welcome back to Module 2 on Energy and Astrophysics. And this is part 3. It's all about the formation of the universe. So here we're really going to see the astrophysics stuff come to light. So in the previous video we discussed the idea of energy, as well as that energy cannot be created nor destroyed. And we also grouped together certain forms of energy based on whether they fall under the category of kinetic energy or potential energy. The question now is, where did this energy come from? And the answer lies with the Big Bang Theory, of course, and no, not the TV show. I'm talking about the leading explanation behind the formation of our universe. Wikipedia and other sources define this as the prevailing cosmological model for the observable universe, that which we've seen from the earliest known periods through its subsequent evolution and continuous expansion. So otherwise, the Big Bang covers the initial surge of energy, which marks the beginning of the universe and time as we know it through a scientific lens. And this is all based upon the many years of observations by many scientists all over the world. And one astronomer in particular, whose name may sound very familiar, Edwin Hubble, yes, of the giant telescope that has brought us so much information about space and our universe. Well, anyways, in 1929, he observed that galaxies were moving away from each other, with the farthest ones moving faster, which told Hubble that the universe was not a fixed amount of space, but yet it's expanding at an increasing rate over time. And the makeup of the universe, stars, galaxies, planets, black holes, it all continues to evolve and change to this day. So, the Big Bang Theory, it's a heavy concept for many, one that is still up in the air for debate, but nonetheless, there is little evidence that can refute this theory at this point, and so it has withstood the test of time. So how does this start? Well, according to the Space Place website from NASA and information from this graphic, the theory suggests that in an instant, we're talking a fraction of a second, right? The universe expanded from one microscopic point, right, the size of an atom, literally, right, and then expanded from that. This inflation then occurred at an extreme rate during the first fractions. I'm telling you, fractions. Look at these numbers here, right? At the beginning. And so we must note that when I say fraction of a second, note where 1 second lies here and also on this graphic here. All right. So during these first few seconds, or fractions of a second, I should say, the universe was a superheated soup of hot and tiny particles mixed with light and energy from all the intense high energy particle reactions going on. The temperatures were beyond anything we can even comprehend on our planet. We're talking temperatures ranging from 10 to the 27th power Celsius up to 10 to the 32nd power Celsius. And if that's too much for you, like it is for me, let's just remember that when it all began, it was really, 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 really hot. Okay? Now this graphic is a great look at all the different particles that filled the universe, this super, super hot universe, prior to what we currently know as the universe with planets and stars and galaxies. That all came later. So in the first split second, right, the teeniest of particles are present. Quarks, gluons, photons. All right, split second after that, protons and electrons are formed. In the first few seconds after that, nuclear fusion can then begin, and that begins to form the first nuclei. That leads to the developments of the first ions about 1,000 years later, and several thousand years after that, the first atoms begin to form. We see that here. Now, these first atoms were predominantly hydrogen and helium. And something special at this point, about 300,000 plus years in, is that light energy was finally able to shine through the universe. You see, prior to that, it was technically too hot to shine due to the plethora of free protons and free electrons that were blocking the light. Okay, so now light can shine as we know it. Now, as everything continued to inflate, expand, and take up more space, the universe finally began to go through a cooling period, with the temperatures going, from 10,000 degrees Celsius down to negative 200 degrees Celsius. And then over the next 1 billion years or so, and please keep in mind that we're only approximately 1.5-ish billion years into the over 13.8 billion year history, estimated history of the universe. But what happens next is that these gaseous hydrogen and helium atoms, all these gases, begin to coalesce or collect into giant clouds of gas. Right? Well, those giant clouds eventually become galaxies. Smaller clouds of gas are also out there forming, and these begin to clump together, and then they collapse on themselves from their own gravitational attraction. Well, these collapsing gases then begin to radiate energy out, and what are these? Well, this is the early stages of our first stars. So again, The large collections of gases formed what we now know as galaxies, our first galaxies, while the smaller collections of gases formed our earliest stars. These are all the events that develop what we now know as the observable universe. So if that all wasn't crazy enough for you, all right, the next stuff is even crazier. Fusion begins within these first stars, right? Well, that creates bigger atoms, heavier elements, and then even groups of atoms called molecules. Well, when the life of these stars would end, they have the possibility, based on size, to explode into what's called a supernova. That would send all of these new elements and molecules exploding out into the universe. Well, this led to even more stars being born, but at the same time, galaxies were crashing and grouping together. Add in that star life cycle, right, them being born and dying, you have a ton of celestial material, all of these different elements out there in the universe, light and heavy, all these atoms. Well, then you begin to see even more collections and collections. You see things like asteroids and comets. And then, only some 7 to 9 billion years later, all right, so this is all just a couple billion years in, later, jumping closer to our time, that's when we begin to see the makings of planets and solar systems like the one we call home. All right, so that was all like Big Bang Theory 101. That was a lot of information. So make sure, if you're unsure about what the heck I just went through, go back, watch this again. Do some of your own research. There's a ton of information out there, a ton of articles, and a ton of new space science and universe science coming out, even as I'm speaking. All right, but Big Bang Theory, okay, it's a very some fundamental stuff of astrophysics and what we know currently about the universe. So, if you like it, keep researching it. But the question now is, how do we know all of this, and why is this important to us, especially as budding scientists? Well, we're going to think about that in the next video. So go ahead and end this one, and I'll see you in the next one.